All right, this is number 18 in chapter 4 of the Halliday and Resnick book. It says a moderate wind accelerates a pebble over a horizontal xy plane with a constant acceleration, and it gives us this acceleration vector. And then it says at time 0, we've got this velocity vector. And then it wants to know the magnitude and the angle of its velocity when it's been displaced by 12 meters parallel to the x-axis. Okay, so important sort of things to pull out of this. Constant acceleration is huge because that tells us that we can use any of our constant velocity equations, right? Okay, so because we're looking at the displacement, it says what are the magnitude and angle of its velocity when it's been displaced 12 meters parallel to the x-axis. Let's look at the x motion, okay? So here's the idea. We know that our horizontal displacement is going to be 12 meters, right? So in the x dimension, here's what we know. We know our displacement is 12 meters. I guess I'm being sloppy about my significant digits. I should probably be better at that. We know it's been displaced 12 meters horizontally. We know that our initial velocity horizontally is 4 meters a second, right? And I don't have to put the I because I've indicated that with this little x here, right? So it turns out that our starting velocity, or our initial velocity, is the same as our initial horizontal velocity because it looks like our starting velocity doesn't have any vertical motion to it. All right, now that is going to change because of our acceleration, but right now, starting, all of our velocity is horizontal. All right, now this acceleration vector up here tells me what my horizontal acceleration is. It's 5.00 meters per second squared. All right, and so we want to know what's going on when it's been displaced 12 meters. So let's figure out what our horizontal velocity is at the end of, however much time this takes. Okay, so you should be thinking about constant acceleration equations. Well, one of them that we learned is this: 2a delta x equals v squared minus v naught squared. Okay. So, I guess I don't really need these vector hats on this because technically this is... All right, so here we go. So let's see. Oh, sorry, I should put my x's on here, right? Because we're just looking at the horizontal motion at this point. Because that's our displacement, what we know about our displacement. So here we go. 2 times our acceleration is 5.00 meters per second squared times a displacement of 12.0 meters equals Vx squared minus 4.00 meters a second. Don't forget to square it. All right, so solve this mess, and you'll figure out that your Vx at the end of these 12 meters is, and I'm going to keep a whole bunch of significant digits here, and then we'll round it down at the end. Or rather, I guess I should say I kept some insignificant digits. So there's our Vx. So now what we can do is we can find our time. Okay? So our time is Vx minus Vox over the associated acceleration. So for us, our horizontal velocity is going to end up at 11.6619 meters a second. Oops. After starting out at 4 meters a second, and our acceleration is 5.00 meters a second squared. And so the time that you get is, again, completely ignoring significant digits, you get 1.53238 seconds. All right? So, awesome. All right, so now we know what's going on horizontally after it's been displaced this distance, but we need the overall velocity. So now I need to find my vertical velocity. All right, so what I'm going to do, let's free up a little bit of board space here. Oops. That's not at all what I wanted to happen. Sorry. So let's free up some board space here. Boop, 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 boop. All right, so now let's take a look at what's going on vertically. So vertically, here's what I know. I know that my VOY was 0, right? Because we didn't start out with any vertical motion. I know that my acceleration vertically is 7 meters per second squared, and I know that my time is 1.53238 seconds, so I can use this guy. My velocity is my initial velocity plus my acceleration times my time. Now I actually do need these little hats here. All right, so figure this out. In the Vy, after you plug in these three numbers here, ends up being 10.72666 meters per second. And so now all we're going to do is we're going to use our horizontal motion and our vertical motion and put it together. So here we go. We're moving horizontally at 11.6619 meters a second. We're moving vertically at 10.72666 meters a second. Find your hypotenuse. So our velocity is, I'm just going to do Pythagorean theorem to get 15.8 meters a second. And then to find this angle, I would use inverse tangent. Inverse tangent of opposite over adjacent. And your angle ends up being 42.6 degrees. All right, there we go. That is number 18. Hope this was helpful.